Welcome back, everybody. We are going to start the last session of the day of the track 10, Applications of the Artificial Intelligence to Cybersecurity. Hope everybody is enjoying the conference. So to restart the section, I would like to invite Yunjia to present his work. Welcome.
Hi, hello. Yeah, shall we start? Hi, good evening, everyone. My name is Yunjia. Warm welcome to my presentation. Today, I'm going to talk about a cost-effective OCR implementation to prevent phishing on mobile platform. So this project has done by 4 people: I, Yang Liu, Tiejun Wu, and then Dr. Ishbel Duncan. So currently, the slug is locked, I think. Okay, currently, I'm a 3rd-year PhD student under the supervision of Dr. Ishbel Duncan at the University of St. Andrews. So my PhD research is about detecting and mitigating phishing threat. In my research, the phishing attacks are classified to 3 parts: general phishing, advanced phishing, and a subdomain takeover issue. So far, the first 2 parts have been done already. So this paper is one part of contribution from them. Right now, I'm working on the subdomain takeover issues. If you are quite interested about this area, either in attack or in protection, so we can talk about it later. So my email has been attached in first page of this slides. So why I pick up this topic from my research and what is my motivation? So according to the data online, so cybercriminals has resulted in a large losses. In 2019, the global loss was $2 trillion. The phishing is a type of social engineering attack. It is one of the most common attacks in the world. The phishing attack has a large proportion of all malicious attacks, as it is always cheap to produce and easy to deploy. A phishing attack doesn't require a high computer scale, but it can result in the victim lose their sensitive information completely. So for PC platform, the browsers such as the Chrome, Safari, they have their security schema to protect users from phishing attacks. Any malicious website will be blocked and warned. However, mobile platform has less security protection to defend against the phishing. So in one of our experiments, so we picked 30 phishing URL from Fish Tank, and all of them can be reported by PC browsers. So when we access this URL in mobile browser, so only half of them can be identified to phishing. So we can see in Android system, only 14 URL were reported to phishing, but in iOS system, in Safari, they have 17 URL has been blocked, but in Chrome, they will miss all of them. So the mitigation of the phishing is worth to be researched, particularly on the mobile platform. So what is current solution to protect the phishing? They have 2 general approach to mitigate phishing: blacklist and heuristic based. In blacklist, the targets in blacklist, most of malicious URL has been stored in a list named as blacklist or block list. When a user accesses a URL, the target URL will be checked from this list. If this URL can be indexed in this list, so which means this target URL is the phishing. So in the second approach, heuristic based, the phishing can be detected through the characteristic of the target. So the content of URL will be checked. So they have some machine learning approach, such as lexical analysis and host-based analysis. But the both approach have the limitations. In the blacklist, this method is not dynamic. So the newly created phishing website will not exist in this list. So which means this newly phishing website will be missed from the browser. But in the second approach, when we gather the information for the training site, so we have to face some restrictions due to the EU's general data protection regulation, because some information is quite privacy, such as register information or server information. So we have to give we have to provide a new, a better solution to overcome all of these challenges and limitations. So the last year we published a paper in the same conference. So we presented a normal method to prevent phishing by using OCR technology on PC platform. So what is OCR? The OCR is optical character recognition. So in this project, so two requirements we have to require before the experiment: the Google OCR API and the Google Search API. The specific OCR procedure was divided to 4 steps. The first one is to extract the logo, and then recognize logo, and search the official, and the last one is verification. So imagine for us, for human being, so how can we identify a phishing? So what is our detection procedure? So we have to know what is this website is and what they require. So we call this procedure is the purpose of the website. From the content, such as logo, background image, so we can confirm it. So for example, if there have a PayPal phishing website, from the logo, we can know, okay, this is the PayPal. And from the content, the website, we can know, okay, they require me the PayPal username and the password. And then if we know the purpose, so we will know what the official link regarding this website is. So finally, so we can confirm whether the target URL is phishing by comparing this target URL to the official URL. So in our solution, so we implement the same procedures, use PC to replace the human being. So firstly, so we need to confirm the purpose of the target website. So we use web crawler to extract the logo image from the website. And both HTML code and CSS file will be considered as the logo image will store in different paths. It is subject to the website. For example, for Google, they store their logo in HTML, but for PayPal, they store their logo in CSS film. So secondly, so we use Google OCR API to recognize the content of image from the logo. And subsequently, according to the results from the OCR API, then we then use Google Search to get the relevant official URL. So the final step of OCR is verification. So we use SSL certificate information to compare the target URL to official URL. The 2 elements will be considered due to the verification process: SSL issue by and issue to. Because in the beginning of this experiment, in this process, we tried to use the SSL hash value to verify the consistency of both URLs. However, we found the hash value is different if the 2 URLs are in different paths due to the different location of the company. So for example, the Google in Hong Kong and the Google in UK, they have different SSL hash value. So even they belong to the same company. So what is the implementation and how to implement this OCR technology on the mobile platform? So what is the challenging we have to face? Compared to PC, the mobile has the limited resources, such as the bandwidth, CPU, and the power and the network. The user would not like to consume a lot of resources on their mobile. So the OCR approach needs to be implemented on server side in order to provide the efficiency and reduce the mobile resources consumption. The ideal situation is a plugin script on mobile browser, but as we know, we can't insert a script to a mobile browser. So in our experiment, so we simulate an environment that assume a script on mobile browser by using man-in-the-middle proxy tool. The implementation of the OCR on mobile involves 4 steps as well. So the phase 1, connect to man-in-the-middle proxy. So both mobile and the man-in-the-middle proxy have to be in a same network. So to establish the connection between this mobile and man-in-the-middle proxy. The phase 2, capture traffic and redirect to the server. A Python program has been called in this proxy. The function response is used to handle the traffic flow and capture the network traffic from the server and retrieve the URL address from the request, and then redirect this URL address to the server for the OCR verification. The phase 3, the OCR implementation on the server. So the 4 steps OCR implementation will be executed on the server, and the verification results will be returned to the proxy. And the phase 4, execute response in man-in-the-middle proxy. So according to results from the server, the proxy will execute different response. If the result is safe, so the proxy will redirect the traffic to the real site. Otherwise, the proxy will return a warning page to the user. We can see it from this chat. So the mobile send a request and to the proxy that we can imagine this 2 parts is a functional mobile browser, and this proxy will retrieve the URL and send this URL to the server, and the OCR implementation will execute in here and return result to the proxy, and the proxy according to the results, and they can the proxy can redirect to the real site if the result is safe. Otherwise, they will return a warning page back to the mobile. So this is the whole implementation on the mobile platform. So for the evaluation, so we picked 20 malicious URL from Phishing tag randomly, and then we use a separate browser to detect the results. So only eight URLs, 40% were reported to phishing. If the separate does not execute our schema, but under our approach, so the security have significantly increased. 18 URLs, 90% URL, 90% can be detected to phishing. So we can see, I mean, the security from the 40 is up to the 90%, 40% to 90%. Also, so we simulate a DNS hijacking attack to my mobile, and we use our schema to detect whether we can confirm, we can detect the DNS hijacking attack. Our schema is work as well. What's the limitation for this for this schema? So we have the same limitations as on PC platform. The first one is accuracy of logo image extraction. So a phishing may have a lot of image, even if the logo they may store in different place or the method, such as the HTML, CSS, and all of this situation needs to be considered. So probably it's very hard to locate logo image in the right place very quickly. And the second one is the cost also of OCR API. Right now, the open source OCR API online is not free completely. So any extra used probably will be charged. But if a company, they have their own OCR API, so this probably can be solved. The last one is the efficiency of the server and the cloud API. So both logo extraction and logo image recognition need to be computed. So if the image are massive, so probably this process will be much longer. So some time consumption will need to be considered. So the conclusion, we presented an effective prototype to implement a phishing attack solution by using OCR technology on mobile platform. We highly recommend the broader window insert a function to examine the user traffic before forwarding to the real site. The traffic will then be directed to the remote server and analysis. The browser can then respond with different web page according to results from the server. So in our schema, the mobile device resources would be used up because most of computation process will be executed on the server. Consumption is no different with normal accessing. So our method not only overcome the mitigation on existing solution, but over provide a high detection accuracy rate, even under a DNS hijacking attack. In the last, I have to say, thanks to my university of Los Angeles, which provide me 4-year full-time PhD education, and thanks to CSA, who funded me for my PhD research, and finally, thanks to NIT Focus and the Phishing Laboratory, this is my internship company. We worked together for this project, and they support me and help me to finish my experiment. Yeah, that's it. Thank you very much. Any questions?
Yeah, thank you, Yunjia. We have one question here. If someone has any other question, please leave in the box, okay? Thank you for the presentation. Have you evaluated the time and the spatial complexity of your approach?
The time consumption, it depends on the OCR precise. Because in my experiment, we use the Google OCR API. It depends how many image you get first, and then you have to use the OCR to translate from the image to the content. And if your OCR is better, so this the speed is faster.
Yeah, okay. There is another question. It is an interesting question. Did you attempt to fool your own solution? Are there now ways to get it around? How you could do this?
No, I mean, so far, I don't think they have some security company or the browser use the same method to detect phishing, because I mean, most of the browser, they only use the two solutions, like what I said is a blacklist and the machine learning. So I mean, so that's the reason why this method is normal, because I checked the published paper or I searched from the reference. No one uses this method.
Okay, I have one question about the experiment. Yeah. Do you have a plan to check what is the impact of implementing your solution in the mobile phone? I mean, about the resources consumption?
Yes, I mean, the big challenge, because last year I published the paper, I mean, regarding OCR, and some reviewer asked me the same question. So
yeah,
how can you manage this the technical on mobile? Because mobile we have limited resources. So yes, that's the reason why I present this schema. So we have to use this mobile, and we have to retrieve the URL before referring the outside, and the browser will get the URL to the browser server, and the browser server will examine and retain. So for us, for the mobile, they will no difference for the normal.
Okay.
So everything will consume, will consume on the servers, not in your mobile.
On the cloud, yes. Yeah. That's a good solution.
Thank you very much.
So,
thank you.
Yeah, I'd like to thank you again. Congratulations for your work. The next session will be in 10 minutes. So we'll be here waiting for you guys. See you soon.